Okay, this is part 3 of the video review for the final exam for Integrated Math 3 for the fall. Okay, so let's get started with number 19, 20, and 21, which are the last 3 that I'm going to cover. Okay, so let's start with number 19. It says simplify each equation. Make sure to check for extraneous solutions. So let's get right to it. Part A, we have a square root of 4x plus 5 equals 3. Okay, the first step always is try to isolate the radical. In this case, the radical is already isolated, meaning that there's nothing outside of the radical being added or being multiplied or being divided into it. It's just radical and then whatever's inside of it. So that's perfect. It's perfectly set up for us so we can get rid of the radical by simply squaring both sides. When you square both sides, radical, the square root, and squaring are inverse operations, so they basically cancel each other out, and all you have left is 4x plus 5. And on the right side, what you have is 9. And that's a very simple equation to solve. All you got to do is just subtract 5 from the 9, and you're going to get 4x equals 4. We're going to divide by 4, and you get x equals 1, and you're set. That is your solution. You gotta check to make sure that it's not extraneous. Okay, so to check, take that solution that you got and plug it into your original equation to see if it actually works. So we're gonna plug it in right here. 4x plus 5 equals 3. I'm going to plug in 1 right there, and I'm going to simplify that. That's going to give me radical 4 times 1 is 4 plus 5 is 9. Square root of 9 is 3, and that is true. Therefore, the solution is correct. That's correct. All right, let's move on to B. Radical x minus 7 plus 9 equals 12. I'm going to start by isolating the radical. It's not isolated in this case because of this 9. There should be nothing else except the radical and whatever's inside of it, right? The radicand. So we're going to kick out that 9 by subtracting it. Minus 9. So what we have is radical x minus 7 equals 3. The square root of x minus 7 equals 3. So now what we need to do is get rid of the radical by squaring it, just like in the last example. When you square, squaring and square rooting are inverse operations, so they cancel each other out, leaving you with just x minus 7. And on the right side you have 9. And finally, to finish it, all you got to do is add 7 to both sides, and you get x equals 60. Now you have to test to make sure that it actually works, so we're going to plug it in into our original function, original equation. So we're going to put radical x minus 7 plus 9 equals 12, like that. I'm going to plug in 16 right here. 16 minus 7 is 9, so it's radical 9 plus 9 is 12. Radical 9 is just 3, so 3 plus 9 equals 12. True. It does work. Therefore, our solution is correct. X equals 16. Alright, let's move on to C. The quantity 10x minus 25 to the power of 1/2 equals x. What I'm going to do is I'm going to start by writing it as a radical instead. So I know that the power of 1/2 means square root. So 10x minus 25 equals x. And now what I'm going to do is square both sides, because to get rid of the radical, you square. The radical and the square cancel, so it's just 10x minus 25 equals x squared. I'm going to make this in standard form, write it in standard form by making it equal to 0. So what I'm going to do is I'm going to subtract 10x, and I'm going to add 25. This cancels, leaving you with just 0. But on the right side, you have x squared minus 10x plus 25. And now you're going to try to solve that by factoring 10x squared minus 10x plus 25. I'm going to make a factor tree for this. X factor. So 1 times 25 is 25. Negative 10 is b. Two numbers that multiply to make 25 but add up to make negative 10. I think that was pretty obvious. It's negative 5 and negative 5. So what you have is x squared minus 5x minus 5x minus 10 equals 0. We're going to factor by grouping right here and right there. The first pair, the only thing they have in common is x, so it's x minus 5 and the x outside. The second pair has a negative 5 in common, so it's x. What did I do wrong? Oh, okay, hopefully you guys caught it before me. This should not be negative 10, right? That always, for some reason I put b there. That's not supposed to be b, that's c, so it's 25 that should go there. So plus 25. There you go. We're still going to factor out negative 5. Okay, so it's negative 5, and then what's left? X minus 5. Alright, that makes more sense. And now I notice that it's the same factor, so it's x minus 5. And the leftovers are x minus 5. So it's x minus 5, x minus 5. Which really we could just write out x minus 5 squared. Either way, it doesn't matter because we're going to set it equal to 0, and they're both going to give me the same solution, which is 5. X equals 5 twice. So we could say multiplicity 2. Okay, x equals 5, x equals 5. So the only solution is 5. Test it. You got to make sure you plug it in to see if it actually works. So we're going to plug in 5 into our original. I'm actually going to plug it into this one, the one with the radical already. So it's going to say square root of 10x minus 25 equals x. Plug in 5 to see if it works. 10 times 5 is 50. So it's 50 minus 25 square root equals 5. 50 minus 25 is 25, so the square root of 25 equals 5. And the square root of 25 is 5, so it does work. So there's our solution. X equals 5. Alright, let's move on to D. The cube root of x minus 6 equals the cube root of 3x plus 24. This was also perfectly set up for you. It's already isolated, right? There's two radicals, but each one is by itself on their own side of the equation. Okay, this is good. You want a radical to be by itself on the left and another one to be by itself on the right. If they were both on the same side, you would move one over so that they look like this. Alright, all we got to do now is just cancel the radicals. And since this is cube root, the index is 3, we're going to raise it to the third power. Whatever you do to one side, you do to the other. Cube root and cubing are inverse operations, so they cancel. So it's just x minus 6. On the right side, same thing. Cube root and cube cancel, so it's 3x plus 24. And now what we're going to do is we're going to subtract the x. It's going to be negative 6 equals 2x plus 24. We're going to subtract the 24. And it's going to be negative 30 equals 2x. And then we're going to divide by 2. And that's negative 15. That answer should be correct. We did all our steps correctly. This is a cube root, not a square root, so there is no chance of extraneous solutions. Extraneous solutions only happen if your index is even. Okay. Just to be sure, I'm going to double check it by plugging it in. Okay, it's just to see that to show that it actually does work. So let's plug in negative 15 into both of them. So this is what you get: the cube root of negative 15 minus 6, right? Equals the cube root of 3 times negative 15, negative 15, plus 24. And now when you simplify this, negative 15 minus 6 is simply negative 21. Is that right? Yeah, that's right. So it's the cube root of negative 21 equals 3 times negative 15 is negative 45. So it's negative 45 plus 24. Negative 45 plus 24 is negative 21. Alright, there you go. It does work. Negative cube root of negative 21 is equal to the cube root of negative 21. You have the exact same number on the left as you do on the right. It doesn't matter what that number is, but they are the same, right? Some decimal. Let's look at E. X plus 2 to the 1/3 power minus 1 equals 4. First thing I'm going to do is write it as a radical. this step is not necessary. If you can work with the rational exponents, like the 1/3 right there, then leave it alone. Okay, I'd rather change it into a radical form. Minus 1 equals 4. I'm going to kick out the 1. So it's the cube root of x plus 2 equals 5. And now I'm going to cube both sides. When I cube both sides, the cube and the cube root cancel, so it's just x plus 2 on the left. 5 times 5 times 5 is 125 on the right side. Subtract 2, and you get x equals 123. That should be correct. You can double check it by plugging it in. I'm going to plug it in right here, so it looks like this. The cube root of 125 plus, 123, right? Plus 2 minus 1 equals 4. 123 plus 2 is 125, so the cube root of 125 minus 1 is 4. The cube root of 125, that's 5. 5 minus 1 is 4, and that is true. So therefore, our solution of x equals 123 is correct. Alright, last one in this part, in number 19. The square root of x minus 10 plus 4 equals 7. I'm going to isolate the radical by subtracting 4. So when I subtract the 4 here, this cancels. So it's radical x minus 10 equals 3. Now I'm going to square both sides to cancel the radical. So I get x minus 10 equals 9, because the square cancels the radical. And 3 squared is 9. And then I add 10 to both sides to finish. And I'm going to get 19. Now I'm going to check it by testing it, plugging it in. So I'm going to get radical 19 minus 10 plus 4 equals 7. 19 minus 10 is just 9, so it's radical 9 plus 4 equals 7. Radical 9 is 3 plus 4 equals 7. 7 equals 7. It's correct. Our solution is x equals 19. 20. 4x squared minus 25 equals 0. Wait, that's part A. Oh, there are 3 parts. Okay, so let's start with A. 4x squared minus 25 equals 0, and it says solve. I'm assuming that in these problems they want all of the solutions, including the imaginary ones, if there are some. Okay, so let's see, how should I do this? There's a couple of ways I could go about it. I could add the 25 and then divide by 4 and then take the square root. That's one way of doing it, like this. Add 25 to both sides, get 4x squared equals 25, divide by 4, x squared equals 25 over 4. I know I'm doing this fast. And then take the square root of both sides, and the square root of 25 over 4 is 5 over 2. But I need to include the positive and the negative. That's one way of doing it. I'm going to go a different way because I notice that this is a difference of 2 squares. So I can practice 2 things at once. I can practice factoring, and I can also practice solving the equation. Here's what I mean by that. This is a perfect square minus a perfect square. This is a difference of 2 perfect squares. So I can factor like this. 2x plus 5 and 2x minus 5. I set both equal to 0, just a zero product property. When 2 things are multiplied and they make 0, that means that each one of them is equal to 0, okay? Or at least one of them is equal to 0. So I set them both equal to 0. To solve the one on the left, I subtract 5 and then divide by 2. I get 2x equals negative 5. And then I divide by 2, and x equals negative 5 halves. That's one of them. For the other one, I'm going to add 5, and I get 2x equals 5. I divide by 2, and I get x equals positive 5 halves. So there's 2 solutions. Negative 5 halves and positive 5 halves. This is a quadratic, so 2 solutions is enough. Okay, B, 8x to the 4th minus 81 equals 0. Now this is not the difference of 2 perfect squares because 8 is not a perfect square, right? This is a perfect square and this is a perfect square, but 8 is not. So that's not a perfect difference of 2 perfect squares. So what I'm going to do here is add the 81 to both sides to cancel it and get 8x to the 4th equals 81. Then I'm going to divide by 8. And I'm going to get x to the 4th equals 81 over 8. There's nothing to do there. I can't simplify that. Now I'm going to look for the 4th root of both sides, because that's the way that I can cancel the 4th power. When you take a 4th root, you must remember that there's a positive and a negative possibility, plus or minus. So it's x to the 4th. Oops, nope. Just x, right? Because the 4th root and the 4th power cancel each other. Equals, I know what the 4th root of 81 is. It's 3. But I don't know what the 4th root of 8 is. Okay, it actually doesn't have one because it's 2 to the 3rd power. So I'm going to rewrite that as 3. The 4th root of 81 is 3. And the 4th root of 8. Now, the 8 is 2 cubed. So I'm going to write it as 2 cubed. That way I can turn this into a rational exponent. I can rationalize the denominator. Also, I can't forget to include plus or minus here, because every time you take a 4th root or a square root, there is a positive possibility and a negative possibility. Alright, let's keep going over here. So it's x equals 3, we put there, over 2 to the 3/4 power. I want to simplify this, rationalize the denominator, right? This denominator cannot stay a radical. I can't leave it like this. So remember the trick that I showed you guys. You can multiply by the same base, and all you need is something to make this a whole number. You have 3/4. How much more do you need to make it a whole number? 1/4, right? So you need to multiply times 2 to the 1/4 power on both sides. I mean on the numerator and the denominator. Now on the numerator, all you have is 3 and the 4th root of 2, I mean. 3 and the 4th root of 2. Let me rewrite that so you guys can see it more clearly. That's a 4 and the 4th root of 2. That's this. And the 3 is this one. In the denominator, it's 2 to the 3/4 and 2 to the 1/4. That makes 2 to the 4/4, which is 1. So it's just 2. And also, let's not forget the plus and minus. There's 2 solutions here. Each one has a multiplicity of 2. They happen twice each. Okay? And that is where it gives us our 4 roots. Okay, this is the last one of number 20. X squared plus 4x plus 5 equals 0. And it's saying to solve. I'm gonna, since I see a quadratic and I see 3 terms, the first thing that comes to mind is to try to use x factor, factoring here. 1 times 5 is 5. The b value is 4. 2 numbers that multiply to make 5, but when you combine them, they make 4. 1 times 5? Nope. Negative 1 times negative 5? Also no. Doesn't seem like it works, does it? Alright. You know what that leaves us with? The wonderful quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac c all over 2a. There you go. All you got to do is just plug in the correct values. Here a is 1, b is 4, and c is 5. So b is 4. That goes here. That's another b. This is a, this is c, and this is a. Simplify this. And we're going to get x equals negative 4 plus or minus the square root of 16 minus 20 all over 2. That's x equals negative 4 plus or minus square root of negative 4 all over 2. I'm going to keep this going over here. That leaves me with x equals negative 4 plus or minus, see the negative inside of the radical? That's I. So it's I radical 4, right? I'm going to leave it like that for now, and I'll do the next step afterwards, so I don't lose you guys here. So the negative inside the radical is I, but I know what radical 4 is. Radical 4 is just 2. So this is just 2i. X equals negative 4 plus or minus 2i all over 2. And now notice that all of them are divisible by 2, so you can actually divide them all by 2. like that. We form a nice little heart right there. X equals -2 plus or minus I all over 1. Since it's over 1, I really don't need to write it. So there's your two solutions. And you can write it like that, or you can split them up into two solutions, which is really x equals -2 plus I and -2 minus I. And they are conjugates, right? They always go together. If one of them is a solution, the other one has to be. Those two are conjugates of each other. Those are the two solutions here. All right, 21, the last one. It says, a swimming pool has the given width and length. They are building a sidewalk all around the swimming pool with the given thickness. Find the area of the pool and the area including the given sidewalk. Okay, this is what you guys need to picture. There's a pool. Here's a pool. And the pool has a sidewalk all around it, like that. The sidewalk has a thickness. So the pool has a width. Let's call that the width and call this the length. And the sidewalk has a thickness. That's t. The distance from here to here is t. From here to here, that's t. Right? And it's all around the sidewalk. That's t. From here to there. That's the thickness of the sidewalk. The pool is W and L on the sides, width and length. So the question is to find the area of the pool and the area included the given sidewalk. Okay, so the area of the entire thing including the sidewalk. Let's start with A real quick. I'm going to try to leave my picture there. It's a very good artistic drawing. And we're going to try to find the area of the pool using the information they gave us. Here we go. Let's start with A. What you need to remember is that the area of a rectangle is just length times width. So the area of the pool, let's call it A sub P for pool, is length times width. So in this case, it's just 20 times 30, right? 30 times 20. And 30 times 20 is just 600 square feet. That's the area of just the pool. The sidewalk is 2 feet thick in this case. So what we want to do next is find the area of the sidewalk, of the pool, of the sidewalk and the pool together. I'll do that in a different color. The area, let's call it T for total, the total area. Well, the length and the width of the entire rectangle here is not W and L anymore, right? What you want to know is, what is this total distance from here all the way out there? What is that? And what is the distance from here all the way down here, right? That's what we need to know in order to find the total area. So it's actually really simple to figure out if you just look at it carefully, and you should be able to see this distance from here to here for just the pool is L, right? But the sidewalk is T on each side. So the total distance all the way across is going to be the distance across the pool, which is L. The distance across the pool, which is just L. But add to that the distance of the sidewalk. Now, it's not just T, because there are two sides to this, right? So it's 2T. So it's L plus 2T. And using the information they gave us here, T is 2, so it's L plus 2T, so it's 30 plus 2 times 2, which is 4. It's 34. You could also easily figure out from just looking at this, if the length of the pool is 30 and it's 2 feet on each side, the total is going to be 34. So it's 34, that's the length. What's the width of the entire thing? Well, if this is W, and this is T, and this is another T, it's W plus 2T, right? W is 20, so it's 20 plus 2 plus 2. It's 24. And now you can multiply those out. 34 times 24, according to my calculator, is 816 square feet. So the area of the pool by itself is 600 square feet. The area of the entire thing, including the sidewalk, is 816 square feet. This is helpful for those situations when they ask you, what is the area of just the sidewalk? Then you could split this up into pieces. You could say, well, I'm going to split it up into a bunch of rectangles and then add them all up. But it's easier if you just find the total area, which we just did, and find the area of the pool, and then just subtract. If the area of the pool is 600 and the area of the entire thing is 816, that means that the area of just the sidewalk is 816 minus 600, so it's 216. That's how this is helpful. Alright, let's try this again with B. Here we go. Alright, so for B, I went ahead and already did the drawing for it. Here, there's the pool and there's a sidewalk around it. The width is 10, the length is 15, and the thickness of the sidewalk is just 1 foot, so 1 foot on each side. So that means that if I wanted to find the total distance across, I'm going to go ahead and write that in already so that when I do the calculations, it's already there for me. The total distance across right here is 15, right, because this is 15, plus 1 is 17. This is 17. Same thing for the distance right here, the width of the entire sidewalk area. So it's 10 plus 1 plus 1, it's 12. Using that information, I can now easily find the area. Let's find the area of the pool, just the pool. That would mean length times width of the pool, which is 10 times 15, which is 150 square feet. Done. So that's the area of just the pool. Let's do it now for the area of the entire thing, including the sidewalk. So total area. The total distance across is 17. And the width is 12, so 17 times 12. Multiply those two times each other, and you get 204 square feet. And there you go. The area of just the pool by itself is 150. The area of the entire deck, of the entire area, including the pool, is 204. So if they ask you what's the area of just the sidewalk, then subtract 204 minus 150, right? If the total is 204, take away the pool, and you're going to get 54. That's the distance, the area of just the sidewalk space. Alright, let's do it again for C. Once again, there's a pool. I'm going to draw a little pool right here. There's some water in it. And then I'm going to draw the sidewalk around the pool right there. The pool's width is 20, so 20 meters inside right there. That's 20. The length is 35, so that's 35 right there. The thickness of the sidewalk is X, just X. Alright, so I'm going to put X here. The thickness everywhere for the sidewalk is just X. Alright, so using that, I want to go ahead and already find what the length of the entire sidewalk and the width is going to be. So if this is 35, that means that this right here is 35 plus X, right, because of the thickness of the sidewalk. So 35 plus 2X. That's what that's going to be up here. The width right here of the entire sidewalk is 20, because this is 20 plus X, so 20 plus 2X. There you go. Using those, I can now figure out what my area of both the pool and the sidewalk is going to be. So let's start with the area of the pool. Area of pool is length times width, which is 20 times 35, which is 700 meters squared. Done. That's just the pool. Area of the entire deck, including the sidewalk, is going to be 35 plus 2X times 20 plus 2X. And there you go. Multiply those out to get the final expression and you're done. Let's use a little FOIL to multiply these out. 35 times 20 is 700. That's that one. That one right there. 35 times 2X is 70X. 2X times 20 is 40X. And 2X times 2X is 4X squared. I'm going to put that in standard form. So 4X squared will be first. Then the 70 and the 40 together make 110X. And then the 700. And that is the area, the total area of the pool and the sidewalk together. That means that the area of just the sidewalk, if you guys look, this is the area of the entire thing, including the pool and the sidewalk. This is just the pool, 700. So if you subtract this minus this, and you want to know what's the area of just the sidewalk, it's 4X squared plus 110X. So basically the 700 is subtracted away. Alright, so that concludes our review for the fall final for Integrated Math 3. I wish you guys good luck on the test. Keep studying, keep reviewing. Good luck.